Today, I would like to talk you through some interictal spike analysis of MEG data in BESA and show you how we can get from this situation, a raw data set, to averaging the events of interest to actually finding out where the sources in the brain are located. So let's have a look at the raw data first. So here we have a interictal spike recording of a patient in MEG and EEG, and this is all the channels, so 350 plus channels. We are just going to look at the MEG to start with, and also I've already defined an additional montage of a selected channel, which is the EKG channel, which is present in this recording. So that can turn up at the bottom. Scale it up a bit to see it better. And also I can toggle through the different types of MEG channels using this MEG button, from gradiometers to magnetometers, to make them a bit clearer. Let's also have a look at the filters. So I'm going to reduce the band a little bit, start with, to make the signal cleaner. And I can see that there is some interaction going on between the EKG and the MEG. So let me first of all go and find some similar EKG signals using this search average view command, using the selected channel and running a search to find all these all these EKG events, so we can define a good EKG artifact average. So here are all the individual EKG events. That's not so interesting for me. I'm going to go back to view the average buffer. And the average buffer shows me that I've got a very, very good average here of my EKG signal, and it actually does show up in some of the channels. So now the next thing is to do is to mark this segment that I have created for the EKG artifact. Right click and define an artifact topography for it, and that should be an EKG artifact. Up on the right, you can see how indeed this artifact mainly manifests itself on the lower row of channels. Press OK, and now I've already corrected my data. So what is my result? So I can toggle this artifact correction indicated here on the left with Control E. So switch off, switch it on. Right, and now let's walk through the data and find some spikes. Anytime I come across an event of interest, scale it down a bit, I can actually double click to set him up. Yeah, and here I can see a very good dipolar field. So this is now my role model for finding similar events. And I'm going to mark a few channels using Control and carry the signal. And see if I can find similar events in the data. Again, using my SAV. So now I'm going to put them into the tag number 2, the selected channels. I've got an optimized filter and buffer width, and I can just run through the data and find these events. Okay, that's my result. So I can now review the data. I can throw out any events that seem to have been found in error or that are confounded by other artifacts. I think I'm okay here, and I can go back to my original data together with the average buffers. So this is the buffer that I've now found for my pattern 2. And now I'm going to do something else. I'm going to go to a source montage. So instead of looking at all my MEG channels, I will go and select source and actually select an MEG brain regions with magnetometers and go to my data using this one. And this has a totally different representation of data. So here you really need to look, scale it up a little bit, to look at deflections in single channels. So any spike will most likely only manifest itself on few channels. For example, this channel TAR01, where is it? It covers this type of brain region, so temporal anterior lobe, the radial surface, and I can see that this particular deflection here is a very good indicator that this channel picks up this spike activity. I'm also going to use this channel and this channel to find these kind of patterns. And again, use the SAV and see if I can find similar patterns. They will be logged into the tag number 3. And I'm using the same approach with optimized filters and buffer width, and press OK to run this pattern search on the source level. Yeah, and again, I can review the patterns that were found and decide if I want to keep them all. Just do a little check. The EEG pattern, go to the MEG. So again, we have this classical bipolar pattern. You can see some of the patterns are in both tag 2 and 3, but some are also only in 3, or some will only be in 2. Okay, let me use the original data again. Now what I can do is I can transform these tags into triggers, average over them, and then analyze these averaged data in source analysis. So for this, we have a macro. Just press the F6 button and put it on my F6 function key, and it'll directly run a batch that converts these to triggers and then averages over them. And we should be ready very quickly. So it also converted to an EEG montage, but I want to look at the MEG now, the recorded data, and I can see that on the left side I have my EKG. This is my first spike, this is my second spike. So now let's do a source analysis on this. So I'm going to mark an interval. I'm going to set filters. So basically I will look from 3 to 40 Hertz and press Ctrl S to start the source analysis. Comes up in the second screen, but I can move it over here. And we can see we have a baseline here. And also we have a rising flank of my global field power. So let's just start by looking at this rising flank. And I can see that very much the whole activity is covered in this first PCA component. So I can just start a fit, and that will set a dipole and fit it. And I can look at the anatomy of this. Select the source and see where it lands in the individual 3D anatomy. I can run a Clara analysis, which is a distributed source model that we could use to contrast our dipole fitting with another method. that'll go through the same interval and show us the mean activation in that interval. Now it's finished, and I can see that it's almost co-localizing with the dipole. Let's just have a look at the residual, switch off the data, and we can see there's a second peak here that could be useful to model. So maybe there's some propagation. Let's just mark this interval. And add another source and start fitting it. And yes, indeed, we have a propagation from this first side to the second side. They're only a couple of centimeters apart, but it's definitely happening. When we see it in the maps, let's double click and have a look at the maps. So let me go through with the cursor. This is the initial peak. And now we can see a rotating map. So indeed, we have a transformation into a slightly different organization. So we can conclude that there is a propagation of this activity. Now, what about the average we did with the source montage? Let's just do the same analysis here. We switch off this data, look at the data of this second average, and do the same thing again. I'm going to look at the rising flank, place the dipole and fit it. And basically it localizes at almost the same location as my first dipole did. Then let's also have a look at the residual. It's also here. Place the second dipole, start the fit. And also we have a propagation here. So these two results are very close together. So this also gives you an idea of the spread. Another thing we can do is look at the confidence volume. So if I zoom in here, I can see confidence volume of this dipole. It's quite high. So we can see there's actually pretty good confidence that we'll land in this region. So compare to this other dipole here. It is indeed inside the confidence volume of this first dipole. So they both complement each other. Thank you very much for listening and watching.